Okay, welcome back to COSC 1436. This is the third video for chapter 5, and it's going to cover how to use for loops, which is the third and the last loop that we're going to be learning for that is used in C++. So there are no more loops in C++. So we started talking about the while loop, which was the pretest loop. Then we looked at the do while loop, which is a post-test loop. And then now we're going to look at the for loop, which is also a pretest loop. So I'm going to go ahead and share my screen. So starting with section 5.6 and for loops. Okay. So the for loop is useful for counter control loops. So a loop where you know either exactly how many times it's going to, that you want to loop something, like you know that you need 5 test grades, so you're just going to count 1, 2, 3, 4, 5. Or maybe you don't know exactly how many grades you have, but you have a variable. You ask the user, how many grades would you like to enter? And then they type a value, and then that value that they enter can control how many times the loop iterates. Now, I'll say this, anything that you can do with the for loop, you can do with the while loop and the do while loop. You know, so you really can use these loops. You can use a do while loop or a while loop as a counter loop, but you just don't see programmers using, like, if you have to count and you know how many times something's going to iterate, we just don't use any other loops except the for loop. It's just what is used because that's how we use it. So you can use the other loops, but you'll see that they're always used when you know how many times you have to iterate. So the key word that we're using for this loop is for, has to be lowercase. We have an open parentheses and a closed parentheses. The first thing that we want to have inside those, we're going to have 3 things inside the parentheses. And initialization, so our counter, if we're going to count, we need to decide where we want to start. So we can start counting at 0, we can start counting at 1, we can, if we're counting by 2s, we would start at 2 and then go 2, 4, 6, 8. So you can decide where to begin counting. It doesn't matter where you begin. You can count backwards, you can count forward, you can count by 1s, by 2s. Okay, so we have to initialize and decide where we want to start. Then this here in the center is going to be the condition. So we're going to test to see where we are in that count. So if we're getting 5 test grades, then we want to keep going until we reach number 5, the 5th test grade. And before I forget, let me make sure that I set my phone to, because I'm getting alerts, to do not disturb. Okay. And then this last thing here is it updates the counter. So if your counter starts at 1, then this statement here called update would increment the counter by 1 or by 2, depending on what you decide. You can count by 5s, you can count by whatever you want, you can count backwards. And then the statement that you have here in the middle, or you could have a block if you have the open and close curly braces, those statements get executed the number of times that you decide that this loop is going to iterate. There's no semicolon that you're going to put here at the end of the for loop. If you put a semicolon, it will just stop the loop. Most likely it's not going to give you an error. And I think this also depends on the compiler. I'll check the compiler that we use online. Okay, but no semicolon here at the end. We want close curly brace, open curly brace, close curly brace, so block if you have more than one statement. So when you have a for loop, the first thing that happens is the counter gets initialized. The second thing that happens is that we evaluate to see if it's a true or false statement, the test. If it's false, we're going to terminate the loop. And third, we execute or update the reevaluated test and then reevaluate test expression. So we initialize, we test. If it's true, we go inside and we execute this statement. We go back here, we update our counter, we test, we execute the statement. If it's true, we update the counter, test. So the very first time you go into the loop, you initialize the variable. After that, you don't deal with that initializer ever again. You test, statement, update, test, statement, update. And you only update the variable if this test is true. So here's an example. We have a variable called count. Count here is initialized to a 1. We're going to check to see if this counter is less than or equal to 5. If it is less than or equal to 5, we're going to print the word hello. And then we're going to increment our counter by 1. So the first time we go into the loop, count gets set to 1. We check 1 is less than or equal to 5. So we print the word hello the first time. Print hello. Now we go to count plus plus. Count gets incremented to a 2. And we check, is 2 less than or equal to 5? 2 is less than or equal to 5. So we print hello. We go back to count. Count is now a 3. Is 3 less than or equal to 5? It is, so we print hello. Go back to count. Now count is 4. Is 4 less than or equal to 5? True. Now hello, print again. Increment count to 5. Is 5 less than or equal to 5? Yes, so we print hello. Increment count to 6, so 5 plus 1. Now we're at 6. Is 6 less than or equal to 5? No, that's false. So we exit and we printed hello 5 times. This is how many times hello would print. And this here explains what I just did. So you can read that if you want, or just watch my video. Hopefully it made sense. Okay, so, here's a flow chart. We assign 0 to count. So this is this is a flow chart. It says for the previous example, but oh, for this example here. Okay, so in this example, count is set to 0, and we're checking to see if count is less than 5. Okay, so this one is a little bit different than this one, because this one was set to 1, and we were looking to see if it's less than or equal to 5. So here, this is good. It's an example, you know, that we can start our count any way, any number we want. So if we start at 0, that's fine. We're going to go to 0, 1, 2, 3, 4. And when we get to 5, 5 is not less than 5, so it exits. So it still prints hello 5 times. So your counter can start at any number. You can increment any number. Okay. So the flow chart, we assign 0 to count. Is count less than 5? Yes. So we see out, we increment, we check. If it's true, see out, increment, check. So we never go back to assigning 0 to count. This statement here only gets executed 1 time. So here's an example. This is the same program that we did earlier, where you have, you're going to have this I'll put one squared is 1, 2 squared is 4, like that. But this time, instead of using I believe we used a while loop last time for this example, we're going to use the for loop. And this is a perfect thing to use the for loop for, because we know that there's 10 numbers that we want to see the square of those numbers. So there's exactly 10 numbers. So let's just go ahead and use the for loop. Okay. So my for loop starts at 1. There's the 1. We're checking to see if it's less than or equal to 10. And then we increment by 1. And it's going to do this for every number until we get to 11. So 10, at 10, 10 is less than or equal to 10. So it prints 10 times 10. Increments to 11. 11 is not less than or equal to 10. So it doesn't print 11 times 11. But you do need to know that when the for loop exits, your num variable, it's not 10, is 11. So it prints the 10, prints the 100, increments this to 11, but it doesn't print it because it doesn't, because this is not true with the 11, num less than max number. This is the flow chart. You can look at that on by yourself. In any situation, when to use the for loop. So you want to use the for loop in any situation that clearly requires you to initialize something. It has a false condition to make it stop, and an update needs to occur at the end of each iteration. Each time you iterate, there's an update that happens. Okay. For loop is a pretest loop, just like the while loop. So while loop and for loop, those are pretests. They're pretest because they're testing the condition at the top before it enters the loop. So your loop could potentially never happen if that condition is not true. So if this condition here is not true the first time, then the loop never will happen. The post-test loop, remember, it's going to iterate one time. Not iterate, but it will go inside the loop one time and then check. So that's post. It checks after it goes inside once. Okay. All right, so we got for loop tests this expression before each iteration. The following loop will never iterate. So here's an example of something that will never happen. If we set count to 11, 11 is not less than or equal to 10. That's false. So it will just exit and not print hello. Okay. For loop modifications. You can have multiple statements in the initialization expression. So this is some ways that we can play around with the for loop. I will have to say that as someone who's worked in corporate, who's programmed, and whose programs have gotten reviewed, something that we always tell programmers is you want to make your code as clear as possible for the next person that comes in to edit your code. You know, if the changes have to be made or bug fixes have to be made, you want to make sure that the code is really clear. So sometimes these modifications, these things that we can do with the for loop, don't make our code really clear. So I'm going to show you what they are because they're here and they're in your book, but I wouldn't say that they're all of them are really something you should do. Okay. So here you have two variables. You have the variable X and the variable Y. And there's two things that we initialize. We initialize x to 1 and y to 1. When you're initializing, you're separating them with a comma. So you have x equals 1 comma, y equals 1 semicolon. In this particular program, we output x and we output the word plus. We output the variable y, which is 1. So the first time this is 1 and this is 1. And then we output the word equals. And we output the sum of x plus y. So 1 plus 1 equals 2. New line. We increment x. We're not incrementing y, just incrementing x. So now x is 2. We say 2 plus 1 equals 3. Increment to a 3. X is now 3. 3 plus 1 equals 3 plus 1 equals 4. And we go back to 5. 5 is less than or equal to 5. 5 plus 1 equals 6. Increment to 6. 6 is not less than or equal to 5, so we stop. You can also have multiple statements in the test expression. Separate the statements with the comma. So this is actually where you increment just a second, let me see what they. Okay, so if we go back way up here, all the way. This is the test expression. This is the update expression. So I think the PowerPoint just has a little mistake in there. So this is initialization. This is test. Yeah. So this is not the test expression. This is where we increment. Okay, so forget that right there. So here we're incrementing x and y. So every time that it iterates, it's going to say, like the first time it'll say 1 plus 1 equals 2. The next time it'll say 2 plus 2 equals 4. 3 plus 3 equals 6. 4 plus 4 equals 8. 5 plus 5 equals 10. And then it stops because x is going to be a 6. The other thing that you're allowed to do is omit initializing your expression if you've already done it. So if you create the variable num and you initialize it to 1 here, then you don't have to initialize it in here. So you just put an empty semicolon. I don't like this. This is ugly. I would say don't do that. That's just ugly. The best way to do this is to define this you see a lot. Define the variable inside the for loop. You do see this a lot. So you initialize and define it at the same time. Now, if you define it inside the for loop, you cannot use this variable outside the for loop. So once you exit the for loop, that the scope of that variable is no longer available. You can't say out here, see out num. So you can only use this variable inside the loop. Okay, so let's take a look at some of this stuff here. So let's say I have the variable x and for x equals 0. So I'm going to initialize inside and I'm going to just count to 5 like I did earlier. C out x. Okay, let's just do something really simple. ENDL. run it. Print 0, 1, 2, 3, 4. Okay, perfect. We started at 0, remember? So that's why it printed 0, 1, 2, 3, 4. If you want to see 1, 2, 3, 4, 5, then you have to start, you have to initialize at 1, and you have to say equal to 5 because you want the 5 to print. So you got to include it by saying equal to 5. Or, so 1, 2, 3, 4, 5. Or you could say less than 6, right? So you could do that, and then that will print 1 through 5. One, two, three, four, five. 1, 2, 3, 4, 5. All right. Now, if I don't need that X for anything, well, first of all, let me just put it back. Once I exit, once my loop is done, I'm going to show you something. I'm going to say, done with the loop. X is now. So I want you to see the value of X. Okay. So it's gonna output done with the loop. X is now, and then here X is going to be a 6. When it exits, it doesn't print the 6, but it has to be a 6 because that's what makes the loop stop, is the 6. All right, so we could do that. If I define X inside the for loop, I don't have access to that X here. I cannot print it. So I'm actually gonna get an error when I try to compile, and it's going to tell me use of undeclared X. So it's telling me that X is undeclared. I haven't declared anywhere. And the reason I haven't declared it, it doesn't know it's been declared because it's the scope of X here is just in the for loop. I would have to declare it up here for me to be able to print it here. Okay. So that's the scope, and the scope is always it's sometimes difficult to understand where the scope is, but you'll get used to it as you do more of these. Okay, so keeping a running total, for loops are really good for accumulating. So accumulating meaning, let's say that I have you enter 5 test grades. So you enter all 5 test grades by using my for loop, and I want to get the sum of my test grades. As I get the sum, I accumulate, as I get the tests, I want to accumulate them. So I just want to show you what that looks like. So let's say I'm going to get 10, I'm just going to get 5 test grades. And I actually like to use less than or equal to 5, just because I know we can start at 0, we can go 1 to 6, less than 6, but I wanted my code to be really readable by people who are going to review it, by somebody that comes behind me to check on a bug or something that's in my code. So, or needs to add to my code. So here's just really clear that I just want this to iterate from 1 to 5. Okay. And then I'm going to get an accumulator. The accumulator is going to be the sum of the grades. Now, whenever you have an accumulator, you've got to start your accumulator at 0. You want to make sure that you begin with a clear, your memory is clear and only has 0 value. So I would say cin, enter a test grade. I'm sorry, not cin, cout. Then I need a variable for test grade. test grade. Here, I'm assuming my test grades cannot be anything but whole numbers, so I'm not going to be allowing a decimal number. I could make it a float. And then I'm going to accumulate. The accumulator looks like this. The variable that you use for the accumulator will be in your assignment statement twice. Sum of grades equals sum of grades plus test grade. And this is your accumulator. The first test grades gets 0 added to it. The second time around, now we have this value plus the new value. And then here, done with the loop, I could just output sum of grades is make it a complete sentence here. Sum of the grades. You could say sum of the grades or total of the grades or whatever. Okay, and then sum of grades. So that's my variable. It's got to be exactly, my variables have to be spelled exactly like I defined them. Everything looks good. Yep. Okay. We're going to run, enter test grade. So I'm going to enter all 90s. I'm going to enter all 100s. So it's easy for you guys to quickly see that it's 500. So the sum of the grades is 500. So there's 1, 2, 3, 4, 5 100s, and the total is 5. So we used an accumulator. This is the accumulator. Like we said in one of the previous videos, another way that we could write this statement is sum of grades plus equals test grade. So this is a shortcut. We add test grade to sum of grades and we assign it to sum of grades. So that's a shortcut for doing this here. So this is, this here is accumulating num. So num is getting accumulated. It's using a while loop. So every time that we iterate, we increment num, and we're accumulating. So we're doing 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 is 3. Then we'll do 3 plus 3 is 6. Then we'll do 6 plus 4 is 10. Then we'll do 10 plus 5 is 15, and on and on and on. Here's the logic. So you can take a look at, spend some time, look at the flow chart. This here is a running total. We're keeping a running total. So we have number of days. We have an accumulator. It's a double. And we ask the user for how many days do they have a sales amount that they'd like to enter. We have a loop that is going to start at 1. It's going to go to the number of days. So in this case, every time you run the program, days is going to change. So you could enter sales for 5 days. You could enter sales for 3 days, 8 days, how many times you want. So here in our program example, let's say we don't know how many test grades. We can ask the user, how many test grades would you like to enter? CN num. So num would be here instead of a 5, and I would define num up here. So if the user enters 6, then my loop will iterate 6 times. If the user enters 3, then it iterates 3 times, etc. Oh, let's see, let's run it. Run. How many test grades would you like to enter? I think I want to enter 3 test grades. I'm going to enter a 3. Here's test grade 1, 2, 3. Total is 270. Okey-doke. Okay, sentinels. The sentinel value is a list of values that indicates the end of data. For example, negative 999. So if we're asking the user to enter test scores, we're going to use a number that's completely something that's not a test score. And it's just something that could help us to end the loop. So use to terminate input when user may not know how many values will be entered. So for example, we would say, enter the number of points your team has earned so far in the season, then enter a -1 when you're done. So here we say enter the points for the game. So let's say the game, for game 1, sorry. So enter the points for game 1. So for game 1, let's say they enter 50 points. 50 is not equal to a -1. It looks like they're accumulating the points. They're increasing game. So here we're going to increase game that started at 1 to a 2. Enter the points for game number 2. So let's say that game number 1, they scored 50 points. Game number 2, they scored 40 points. So enter 40 here. Go back up here. Is 40 points not equal to a -1? Well, it's definitely not equal to a -1. So now we're adding the 50 from the first game plus the 40 from the second game, and we're accumulating inside total. Now we're at game 3. Enter the points for game 3. Let's say there wasn't a game 3. So I'm going to enter a -1. And then that -1 makes the loop stop. It means that I'm done entering values. So here's an example. They scored 7 points in game 1, 9 in game 2, so on and so forth. There was not a game 6, so they entered a -1, and then 7 plus 9 plus 4 plus 6 plus 8 is a 34. So again, I went over this a little bit last time, deciding which loop to use. When do you know what loop you should use? Because you have 3 options. The while loop is a conditional pretest loop. It iterates as long as a certain condition exists. You can use it for validating input. Use it for reading lists of data terminated by a sentinel value. The do while loop is a conditional post-test loop. So it goes in once and then it checks at the bottom. It's always going to iterate at least 1 time. Use it for menus, or maybe if you want to check also for validating, if you want to check to see if the data is valid, you could use this one also. The for loop is a pretest loop. It has a built-in expression for initializing, testing, and updating. Situations where you know the exact number of how something is going to iterate, this is when you should use the for loop. Okay, so the next thing we're going to look at is nested loops. So these are loops inside of loops. And so I'm going to stop this video now and I'll pick up with nested loops because this is a whole other topic. And then we'll finish off with looking at reading input from files and outputting to files.